started. People will trickle in. Feel free for those who are attending to ask, put questions in the chat throughout our presentation, but we'll start with some introductions. This is the FabX Live presentation of Making Joy using Google Drawings and Tinkercad. Me and my colleagues are here from the Lesley STEAM Learning Lab at Lesley University. I'll let them introduce themselves and then I'll come in. Kreg or Sue can start.
Sure, I can kick us off then. So hi everyone, my name is Kreg Hanning. I'm the Director of Technology and Innovation for the Lesley STEAM Learning Lab. I focus a lot on coding initiatives and just getting people making things with their hands in the physical world and then connecting that back with digital creations. That's what gets me really excited. So with that, I'll pass on to Sue.
Hi everyone, I'm the Director of the Lesley STEAM Learning Lab at Lesley University. I also teach in their Graduate School of Education related to educational technology. Much of our work is related to supporting educators in adopting the maker mindset and helping brave a path to less boring educational experiences for kids out there.
And I am Nettrice Gaskins. I am the Assistant Director of the STEAM Learning Lab and working with Kreg and Sue. We're going to talk to you a little bit about a project we're working on that has digital fabrication involved with it. We're thinking a lot about remote learning specifically. And so this activity is probably a good activity to do it from remotely if you can't do it face-to-face. So let me pull back up the slides. Keeps giving me whiteboard, and for some reason, let me pull it, try it again. Okay. So to give you a rundown of what's happening, we did our introductions. We're going to move into frameworks. I'll do that part. Kreg and I will talk about instruction, and Sue will come in when she can, and we'll do a Q&A. So for this activity, I was thinking a lot about the impact of remote learning and not being able to be in the classroom for a lot of our young people that we don't directly serve, but they're teachers, and then also just in some of our interactions with young people as it relates to the pandemic. And it's more specifically their emotions, how they're feeling. And then one of the things I noticed, we did this sort of instructable for middle school age students. There was, I couldn't really find a book that just focused on joy or emotions that were positive or trying to sort of cast a different way of looking at circumstances that many of the young people here in the United States are in, and many in other parts of the world as well. So in terms of frameworks, and social emotional learning is sort of related to this. It relates to where children and adults understand and manage their emotions. They set and achieve positive goals, feel and show empathy for others, and establish and maintain positive relationships and make responsible decisions. The activity we're going to talk about kind of fits in the self-awareness and the social awareness, well, between those two, but it could also relate to some of these other elements, features that you see here. But more specifically, there's another idea around self-concept that represents the individual self. It's a collection of beliefs one holds about oneself and its responses from the world. How these things embody the answer to who am I? So there's self-esteem, there's the ideal self, there's the self-image, there's the way there might be unfavorable societal responses, and then confidence, it may impact confidence and self-worth, so socially valued outputs, and then that has all mixed together. And then how one sees themselves, and specifically as it relates to making and to STEAM and STEM education in terms of where students might see themselves, and do they see themselves as makers? Do they see themselves in a fab lab? Do they see themselves doing digital fabrication? And that I kept that in mind for this activity. So for the next 40 minutes, we're gonna actually look at an instructable that has all the steps that we're gonna go through today. And this is the Make Joy using Google Drawings and Tinkercad. I will put the link in the chat for those to follow, and we'll follow, and I'll share the screen again and we'll go through it. So let me just do that first. And put that into the chat. Meeting. So that is the chat. Oops. And so now we're going to go through that activity step by step. So if people would just mute your microphones for a moment while we talk, and then you'll be able to ask questions along the way, and as well as in the chat, and we'll answer it at the end. So this is the Instructable we wrote and worked on, the project we worked on for this. And it talks a little bit about, you saw this in the description, of converting two-dimensional graphics into 3D models and to represent themes or concepts from literature. So we are working with the public library here in Cambridge, Massachusetts. And so there is a literature reading analysis part of this activity. It's also, the latter part, the fabrication part, is inspired by Nick Cave's Until, that was on view at Mass MoCA from 2016 to 2017 in this massive football field-sized immersive installation, which has since traveled the world. So you might want to get a book that has, reading a grade level with an idea or concept or title that sounds really cool, a story that sounds really cool, and then you'll need some clip art, stock photography. You can also use your camera or smartphone to take photos, and Google Drawings is a online, you just click the link here, or you can go to just Google Drawings, which will bring you to the program, and then a Tinkercad 3D design. As optional, because obviously if you're doing this remotely, it may be harder to do, but you can use a Final Cutter or laser cutter or 3D printer to fabricate what you create. So step one is front loaded with that whole idea of self-concept and what young people sort of envision, or students imagine themselves as it relates to STEM and STEAM. So this is some examples of some texts that relate to, in my case, I was really thinking about joy of learning, joy in general in terms of what people do outdoors. It's the summertime. But there's these kind of 4 areas of self-concept: who I am now, how I'm seen by others, how would I like to be seen by others, how am I or would I like to be to myself, and who would I like to be. And so finding a grade level, age appropriate book, such, Love Double Dutchess, you can see a screenshot in the Instructable. There's also Ada Twist, Scientist, which Kreg found and used for his version of the project, which he'll talk about. And so after you read and review the self-concept types, which is more relevant to characters in the story, to whoever's to the reader, then you make a list of those ideas and concepts from the reading. So you can pull out joy of jumping or something else that you might want to be able to do an online image search around. So I'm actually going to pass step 2 to Kreg to talk about his process, which is here included in the Instructable. Kreg, you can go ahead and do that and just talk through your process, and I'll just kind of do a scroll of the screen.
Sure, yeah. So I chose the book Ada Twist, Scientist because this is one of my favorite books to read with my nieces. Not only does the book itself convey joy, but it always brings joy to everyone who's reading it. So this is the one I thought of when I got the assignment. So I just went to Google image search and I typed in Ada Twist. I tried a few different search terms like Ada Twist clip art, just to try to really find that, that image I was looking for that was expressive, that I was hoping to trace out. This one, you can notice there's a lot of background noise in here, which it made it a little bit more tricky than if you can find something that's a little more isolated like you see in the first 2 images. But either way, you can make this work as you're going through the process of tracing it. So once I found my image there on Google image search, I just saved it to my computer. And then I opened up Google Drawings and I imported it in there. You can just copy and paste between the two. It usually allows that as long as you can get a copy of the image. So once you get it into Google Images, this is where you have to start tracing the outline of your shape. One tip I would say, and I think this is in the documents, but don't get too caught up on fine details as you're trying to trace your shape. That was kind of a mistake I made early on, as I was trying to just trace every little line and every little copy on Ada. And then I realized when I imported that to Tinkercad, not all of that translated over. So my tip would be really focus on kind of the big outlines of the shape. What parts of the shapes actually define the character that you're trying to trace. So, I focused on the hair, the body, the clothing a little bit, and that was probably all I really needed to do as I was going through the tracing. So this screenshot here is just showing uploading the image in, and then you can use the paint tool to draw the traces around the character. One tip too is if you click on your image once it's in Google Images and then click on the format options box, you can actually set the transparency of the graphic. And this really helps as you're trying to trace it, because otherwise the lines you're drawing tend to get a little bit lost in the details of the image. So I set my transparency to about 50%, and you can see in the right image there how it really pops out my lines as I'm going through and tracing. So that was really helpful. And then I just used the simple line tool. I did try, like I switched between a few of the different line tools, and you might try that also. There's just the kind of like paintbrush or pencil tool. There's like a curve line, a poly line. So you might try a few of these different ones. If you're not so great at hand drawing like I'm not, I leaned into a little bit more of the predefined shapes in Google Drawing, which was definitely really helpful for me.
I was trying to get it to stop on the trace part.
Oh, right, yeah.
We're all going to give you a chance to try it, but I just wanted to, let's do that now.
Yep.
So Google Drawings, if you are in the Instructable, is in step 3. If you click on the link, it should open up, and then you can see this is what it looks like. So, you know, we're going to skip the reading part because obviously we only have an hour and people have to you know, move on to the next activity. So if you do want to incorporate literature, you may want to do that before this step, just so people know what to search for. But if you have an image, you maybe take a couple of minutes to do a Google search to find a, you know, stock image on Google image search that you can import or insert into this document. So you just go to insert image, upload from your computer once you save the Google image. In my case, see how quickly I can find an image. And it will give you a few minutes to do that. I have a few in here. So you're searching for, you know, a simple image, a cartoon, something that's easy to, you know, easier, doesn't have a lot of detail. And you really want to just trace just the basic parts of the drawing. This one's already sort of traced. Let's see. I might have done this on a different computer, but anyway, I'll do the search part as well. So in this case, I chose Joy Clip Art. And obviously, I do get some jumping kids to start with. I'll use this one. Save this image to the computer.
Oh, it's not showing us this window because I think it's only sharing Google Drawings right now.
Okay. Thanks, Kreg, for the heads up. And so I'm gonna go back to drawings. I found an image that I want to use. And here it is. So once you have it, you can insert it. You can size it up if that's helpful for you. Make it a little bigger. And then Craig's suggestion is to click on the image and then go to format options so that you could bring the transparency down to about 50%. So you've lightened the image, and then the next step would be to trace it. And then you would use where it says the line tool, or usually it has the default. There's a drop down arrow and you would choose Scribble, for example, to draw or trace over your. So I actually did the mouth and eyes in Tinkercad. I really only traced the head and the hair when I did this, and sort of just the outline. It's really that simple. My suggestion is not to use, you can see that in the Instructable example, not too many gaps. in the drawing. So you want to kind of a continuous line as much as possible, because that it's really tricky when it comes to SVGs out of this program going into Tinkercad, as you'll see soon.
I knew there was no way I was going to be able to trace the hair well on my shape, so I ended up actually using the cloud shape, which just happened to match the hair really well. So I actually have two clouds on top of my character's head as the hair, and it actually worked well.
I'm going to actually make this image a little lighter so you can see a little bit more. I have I don't know if you say Wacom tablet, a Wacom tablet. I had to dug it out for this project because I can use the pen on it. I don't have it now connected, but that's also helpful if you had a different way to draw. And make sure you choose Scribble again when you're ready to draw, to trace. And, you know, tracing helps if you know how to draw, then you don't have to worry about this step. You can just draw directly into Google Drawing. See, once you're done with this part where you created a tracing of some sort, you're going to go to File and Download, and you want to download it as a scalable vector graphic or .svg. So when you're done with that, when you have your SVG, you could just put in the chat ready or done so that we get a sense about when we can move on to Tinkercad. See. The tool is called Scribble. So there's a drop-down arrow next to the line tool, and the drop-down, the very bottom of the drop-down menu is the Scribble tool.
Sorry, can you say that again? I just have the arrow and then the box, the shape maker. I don't have that thing between it, the Scribble tool.
Okay. This I'm doing. Can you see this on screen?
Yeah, that's what I'm saying. I don't have that.
The Scribble tool here.
Oh, how do you, where did you?
There's there's an arrow next to,
okay.
and you drop down and the scribbles at the bottom.
There we go. Thank you. I appreciate that.
Sure. And it may take some time to get used to, you know, a new program. So you may want to just spend some time, and that's also in the Instructable, just kind of getting to know Google Drawings a little bit before doing this step.
Also want to mention it also works really well on an iPad or a tablet, so Google Drawings might be a little easier for you using a touch screen rather than a mouse too, if you have that available to you.
And it, you know, and it takes some getting used to just as a different tool. But what I like about it is that it's online. You don't need to download it. And if you're teaching remotely, then if you always have Google Access, this, you know, students can actually just use it and download their SVG files for Tinkercad. So the last step, which is Tinkercad, is probably really short. Most of the time consuming part is the tracing. And the Tinkercad part is really just to prepare it for 3D printing or laser cutting. Someone had a question about Google Drawings can be used for design instead of Inkscape for laser cutting. Yes, you can come away with a SVG file from Google Drawings, which could be used for laser cutting. Inkscape's more robust than Google Drawings, so it is an open source program, but I find that there's some things you can't do, as Kreg is answering in the chat. So for, you know, if you want a cleaner image that's less expressive, you could use Inkscape instead. But yeah, Inkscape can be difficult. It's a you know, much more robust program. This is a simpler program to use, even though I think it does take some getting used to. So let's take about 5 more minutes on this step, and then we'll go and show how to prepare it for a Tinkercad. And if you don't finish it, that's okay. You can always go back. Always go back and do it and use it again. And learn and get more used to Google Drawings.
I don't know if we'll run into this today, but I actually had to go back and forth a couple of times between Tinkercad and Google Drawings, which is nice to just, you know, demonstrate the iterative process. Like if it doesn't look exactly how you wanted it to when you import it, you can go back and make some tweaks and try again.
Yeah, I made a, you know, I think maybe each of the times I used it for this task or activity, I had to use it like, I had to go back and forth at least 3 times. And in some of your, and Kreg, in some of your example, you overlap your lines, so there's no gap. So that might be helpful if you can't do a continuous line. But only a little bit, because if you overlap it too much, it tends to do something wonky, and when you bring it into Tinkercad. And do not do any inside details. This is not the program for it. The process for it, because what you're going to get is a silhouette. It's going to fill it in when it brings it into Tinkercad, so you'll lose all the details. And you know, when you bring it over to Tinkercad, so you just want to trace the silhouette or the main detail, main features of the cartoon. In this case, the legs, the arms, the hair, and maybe the face and the body, the torso. Keep it really simple. It's going to be a silhouette, and that's how it will print. Okay, a couple more minutes, and then we'll, you know, you can let me know. We'll see how many people are done. Looks like we have a few people done at this point. Yeah. Good. Give it a couple more minutes, maybe 1 minute or 2, and start talking about bringing it into. So someone said in chat, Inkscape allows a trace bitmap option, which is great. I use that a lot. especially when doing very flat pieces or pieces that are a silhouette. The problem is many schools, especially in the United States, if the students get computers from the schools, don't have this on their computers, they can't get access to Inkscape. But because of many schools use Google and the Google suite of tools, it's easier for students to be able to get hold of or get on to Google Drawings. So this is why we're taking this step instead of something like Inkscape, which is also free. And if you're a Fab Lab not in a school, or it's an issue around it, and especially for education, about what schools will allow students to have access to in terms of software or tools to do this work. But Google Drawings is an easy way to do it. So yes, we do. Inkscape is great, definitely. And that may be an issue, maybe for the Q&A, to talk about how people are working around that in the schools or in school-based scenarios or classes where they have to use software like Inkscape to be able to create images that can be fabricated. All right, so again, you don't have to finish this step. This is just to get you started. But if you did create your SVG, the next step is to go to Tinkercad. So a show of hands, if you've used Tinkercad before, it's also online like Google Drawings and fairly accessible for people with internet access. And that's in general. I'm not talking about firewalls or other specific issues. And so for this last step is to import that SVG you did. Again, when you import it, it may not look the way you think it's going to look. So you may need to go back into Google Drawings so you could have it as keep it open in a tab or save it and come back later. But you want to choose a file by clicking the button and choosing an SVG file that you have. I have this one here and I click open and I click import. It may take a few seconds. And so it may be bigger than the work plane, which you can then size down. So this is a SVG file, and you bring it in, and I'll usually bring the size down a little bit. And that's really all you need to do. Now, in this case, in many cases, like I added the eyes and the mouth, and I can show you how I did that. And if you've never used Scribble, here's the exact name of the tool name is exactly the same for Google Drawings and for Tinkercad. Scribble will allow you to create the features that you can then add as holes into the 3D model. So the way you would do that is if you click the Scribble over here, one of the shapes tools, and then you bring it out here on the work plane and you click once, it gives you a different version of the work plane. And then I can say I want to do an eyebrow or an eye. Let me fill this in. You know, we can do the eye, you can do eyebrow, you can do lashes if you like. And then when you click done, you actually have that, which you can then put inside of as a whole and I'll show you how to do that. So I've already done that with this model, but what you would do is you bring it over here. As you can see, it's sort of sticking out a little bit. And you can see that you can sort of drill down into the object a little bit so that you can see on the bottom and on the top. And then I'm going to undo this and walk through the steps again for those who need it. But what you would do is you would change it over here where it says shape to whole. And then when you select everything, you can just use Command A or select all on your work plane, and then you'd be able to group it. So if I group this together, I have now have an eye on here. It should go all the way through. Now the problem with this is you can see I have this extra piece right here. So let me undo that. Now the cool thing is if you click that object, you can edit the scribble. So if I wanted to, I could just fill the eye in. So I don't have that extra piece. Make sure all of it is filled in. Click done. So then I won't have that extra piece. You can always go back and edit, similar to, in some ways, to the scribble in Google Drawings. Yeah. Okay, so now when you can add all your features and details that you weren't able to add in Google Drawings to the 3D model that you've imported. And when you're done, you'll be able to export this so that you could 3D print it or laser cut it. So you just go to export, STL for 3D print or .svg for laser cutting. You wouldn't even need to do this step. If you had the SVG, you could just bring it into whatever program you use to laser cut. Kreg, you have anything to add about this step?
All I was going to say is that where Nettrice had switched that to a hole, that scribble to a hole, you could also leave it as a solid if you wanted to have like an additive, or if you wanted to add to the model instead of take it away. So when you're looking at the clip art image, you might recognize, I'd like the nose to stick out but have a hole for the eyes or something like that. So it's really up to you whether you're adding or taking away from your model here in Tinkercad. It's kind of easy to do either one.
Let's say that'll be a nose. So that'll be a nose. Now it's obviously bigger than I need it to be. So just hold the shift key down and then I want to bring it over here. Let me go home out. So kind of what he's saying is you could put, if I wanted to put a nose in the area, let me just zoom in there. I could, in theory, do that. And then I'd have that as kind of sticking out. And I would have to raise it, make sure it's raised up a little bit.
And then I don't know if anyone's been seeing how Nettrice has been navigating around this, but those tools up in the top left-hand corner are so useful, especially if you're like me and you just get lost all the time. They let you sort of jump back to a certain perspective, or you can even click on the square and just sort of drag the square around. And that's one way of panning around the object.
Yeah, you can see this home, and fix view to selected shapes. You can zoom in and out. The top, this cube, allows me to flip around really quickly if you haven't used it before. And I will just check the bottom, for example, to make sure it doesn't come out the bottom. And I'm just getting that. You can change the color of everything if you want. So right now, everything's kind of just, if I wanted everything to be one color, I could do that. Just for my visuals here, it won't matter for the 3D print. It's whatever plastic you choose, color plastic you choose. But this is basically the last step for the at least for this part of the activity. Yeah. And again, you have all the steps we're doing here in the Instructable, including the final step, which is our 3D printed objects, which I'll show. Any Tinkercad questions you can put in the chat. We can answer those for the Q&A. And of course, you could add to this, if you want to put if you want to do more to this, you can. Right now, it's kind of 2D and then extruded a little bit. You can make it even more extruded. You could put a background on it, so it's like on a plate or some sort of background, and then print that. There's lots of ways you could enhance or add to what you brought in from Google Drawings. So once you export it, and you choose STL for, then you get your STL file. You can then 3D print that pretty easily, as long as it's airtight. I mean, no holes other than these shapes here, no like holes in the geometry. This is really simple, so that won't be a problem at all. So Craig, you want to talk about how you 3D printed it while I find the images?
Sure, yep. So I just have an old printer bot, Simple Metal, which is a printer that's been surviving for probably about 7 or 8 years now for me, and it's still going strong, so I'm happy with it. I use open source slicer tools, so I don't know if anyone is familiar with 3D printing. There's a couple of steps. Once you get your STL or your 3D model, you have to slice it, which basically takes a 3D model and then cuts it into little individual layers, which tells the machine how to move and how to extrude the plastic. So I use an open source tool called Prusa Slicer, maybe that's how it's pronounced. And that lets me just bring in the STL, do the slicing, and then I can just export it to my 3D printer to get it to print. So these are the 2 different models that I printed using just 2 different colored PLA plastics. One thing you'll notice is if you look at the polka dots on Ada's dress in this one, they get really close to the edge of the model. And that's another one of these things that I had to sort of recognize that, oh wait, this is going to be a problem if I try to 3D print this. If the holes were too close to the edge, it makes like a really fine little line of plastic that's not really structurally strong at all. So I ended up just backing the polka dots away from the edge a little bit, and now you can see it made a much more, a much stronger object, at least when it actually 3D printed it. One thing is, depending on how big you're 3D printing it, sometimes some of the details start to get lost. So that's one thing you want to look at, is when you're scaling the image up or scaling it down, do you still see those features? So if you look at this one, I think I scaled it dangerously too small, where the eyes and the eyebrows started to disappear a little bit, just because the machine's not able to print plastic at that fine detail. So definitely something to consider. And most 3D printing slicing software gives you like some form of preview before you actually go to the printer, which is really helpful because it helps you identify maybe some problem points before you sink an hour into the 3D printer and then have to start it over again. Okay.
So as a final step, Sue, is there anything you want to add to this? She's in the chat.
Monitoring the chat, and you guys are doing an awesome job. Thank you.
Okay. So there is a final step for this. We actually are working with Cambridge, thank you, with Cambridge Public Libraries. They have a makerspace, a new one, and they have 3D printers. I think they have 3 of them, 3 or 4 of them. And so we thought about doing this as like a installation project. So every student will make one of these, and then they would hang like a mobile or a curtain from the ceiling. Maybe at the library. It could also be moved from library to each of the students' local libraries. So it relates to literature, but it's also this fabrication project, and now art installation, and inspired by Nick Cave's Until exhibition. So these hanging 3D printed objects would be something that could be mobile, but also illustrate what they've read and kind of what they, whatever they learned from what they're reading would be represented by their 3D object.
You could also dial it back. I don't happen to have any of that tech in my home. And so I was ready to just grab the work out of Google Draw and cut it up. And you can build your own mobile, or if you have access to a vinyl cutter, you can also create those shapes and put it on a piece of plastic so that that's portable. I think Emily's in the room. I got all kinds of ideas about how the exhibit can go from the main library, and then individual artifacts can go to the branches where the kids maybe come from, as different ways to highlight student level work.
And I won't play the video, but there's a video from Mass Mocha, which actually has a bunch of student activities around the show that they had, which relate to the idea of social emotional learning and the self-concept idea. So that was actually good to see in this video, which is educational and not just about the artwork, but how young people can perform and act out what they've learned in the art exhibition.
So many possibilities. And tying it to literature, I think, is also just a really interesting opportunity as well. Working with the library, that's a logical connection, but I'd be willing to bet most ELA educators haven't thought about that type of connection that they can do with their students to amplify learning around the character that they really like in a story, or any of those other types of possibilities. Very, very fertile space.
Someone talked about cricket. Was it Jackie who talked about cricket? And so there's lots of connections you can make with, and also machines you could use to create these create the physical version of the 3D model. So let's do some Q&A discussion. We have some time, and I know our partner at the Cambridge Public Library, Emily, is on and in here with us. Feel free to ask any questions you can put in the chat, or we can just talk a little bit about this project more, and or anything else you want to talk about.
So Tony's talking about 3D printing self-portraits, and I definitely have seen that kind of thing happen. We had a really awesome portrait of one of our colleagues that Kreg 3D printed for us, and we made an ornament out of it for her for the holidays. It was thin enough so that it was transparent. You could hold it up to the light.
I would think, go ahead. Okay, Kreg.
I was just going to say, if anyone's looking for that, lithophane is I can put it in the chat too, but lithophane's just, I mean, it's really magic when you see that come out of a 3D printer. Sorry.
I think I did one of Kobe Bryant. I did, and I actually shared it with kids. You look at it, you can see it comes out in kind of 3D.
Yep.
So I'm Emily with the Cambridge Public Library, and just want to say, one, I'm so excited about this partnership. Nettrice has put together something incredible in a had an idea and she ran with it, and we've got something amazing to go with. And I think what's really nice about this is this space. We have this beautiful new Fab Lab makerspace that's close to the community and probably will be for the foreseeable future, unfortunately, in terms of people walking in, and I suspect a lot of people are in the same boat there. But we're having to think creatively of ways that we can get young people involved in making that ties to what they would otherwise be doing here. And something like this, it fits so nicely because it melds with both it melds the makerspace piece and the design work that they would learn in this space. And then also that literature piece, which is just so key. And the melding of these two can run in so many different directions. So we're very excited to pilot it.
We have a comment. Someone said vinyl or laser cutting will allow more students to be able to get their project in one class. Yeah, so you can fabricate it quickly as opposed to 3D printing, which could take overnight or longer. To that point, one of the things that I was going to mention to Emily, but she's right here, is maybe if they do this remotely and they had their Tinkercad models, that it can just be done by one person, picked up or something in a box. So there might be a way to do it. So remotely, they could do it at home, and then they could pick up the 3D print, and one person or two people who can physically distance themselves in the space can fabricate the models.
That's our hope. We've got curbside pickup, so we've already got the mechanisms there for getting materials out. We want to get these machines fired up and making products that the community designs.
I mean, you could affix them to windows, as someone mentioned. You could do this as stickers. You can also do this on clear or semi-transparent, like acrylic, and do kind of light, shine lights and things on it, so that you might get some light patterns on the walls. You might be reflective. You can do mirrored acrylic as well. But you could create effects with the models, really create an installation, actual, light show, so to speak, in a space that maybe the public walks by. So there might be different materials to use in addition to 3D printing. Some more ideas in the chat of creating illustrations. Yep. The format to save the file, again, you can follow the instructable, is a SVG. Anything that's 2D coming into Tinkercad has to be an SVG, or there's OBJ as well, but SVG is the pretty common one. And then once you bring the SVG in to Tinkercad, it will be able to size it up, add things to it. I know this has been recorded, so this is recorded for future, possibly on YouTube viewing. We still have some time. Maybe get some, is there any other things with Tinkercad, or even how would you, Kreg, how would we use to create maybe a moving mobile?
Yeah, that's one thing I was thinking is in Tinkercad, right, you can add all kinds of modifications to the model depending on what you're trying to do. So if it's a mobile, you might add like a little loop at the top so you can hang it. Maybe you just put a little like extra protrusion of plastic so that your 3D model can just sort of stand up on the desk, right? Maybe you wanted to have it as like a desk ornament or something. So once you have your 2D object, then you can get creative and think, all right, now where do I want this to live in the physical world, and how do I adapt it to really work well for that?
And Kreg, you've done some stuff with like silhouettes, right? Dance, was it kinetics?
Oh yeah, doing like kinetic sculptures. Yeah, actually, I didn't even think of that overlap, but that's such an awesome idea. One thing I really love doing is making sort of like moving mobiles with tiny servo motors. And these can be great artifacts to stick to moving motors, because now you can animate it, right? So you take it, you put a servo on the back of it, and now you can animate your character and really convey joy. No, that's such a great idea.
Do you have a video clip to show them?
Sure, let me pull one up. It'll take me just a minute.
Okay. Yeah, because I think the many different options you have are, it's the sky's the limit, kind of, in a sense, because you can try different things and mix it up once you have the media. I've used, the question is, using Tinkercad remotely with students, do you have any experience having them switch from Zoom to Tinkercad and back? Does it work well? We actually have, on spring break, we had a 3D tic-tac-toe group that worked in Tinkercad, and we created a classroom, a Tinkercad classroom for the group, and then they could just put their models into the group, and then every day we would just check back. We did it for about 3 days to see what they were doing. So definitely you could do that, and within the Zoom. And then the teacher who could see the group could share what the students were doing just by sharing their screen to the rest of the class. Kreg, I think you can share when you're ready.
Okay. Oh, it looks like it's disabled by the host. I don't know if you're the host.
Let's see if the host.
I am the host. I am the host now. I can.
Okay.
Wonderful. Thank you.
Thank you, Angela.
Okay. Greg.
Okay, great. Now it looks like I can.
Okay.
All right. So hopefully everyone can see this video now. So this is using tiny servo motors and then just recyclables. So we start with just cardboard boxes, cardboard scrap materials, and a bunch of craft objects. In this case, we actually had a stack of magazine articles too, so people could cut out different words or graphics and use that in their creation. But like Nettrice said, these physical artifacts that we've been designing today would be great to add to something like this, where you can just create this kind of moving mural that sits, maybe it's just a piece of art, or maybe it conveys a message like this one, but that's a really great idea.
So it's worth a shout out to the South End Technology Center for inspiring this kind of work for us, right?
Absolutely, yes, yeah. So South End Technology Center had started a project they called Servos for a Cause, where that was the idea is they would pick a particular cause that was meaningful, and then you would design some sort of kinetic mural around that using servo motors. And they were, doing all of the circuit design themselves. So they were actually designing the circuits, cutting them out of copper tape, and then soldering them with little AT tiny microcontrollers. And they were really doing all of the work. So we were really interested in that work. So one thing we did is we designed this little board. We're calling the Tiny Kinetic, and it basically just abstracts a lot of that away, so you can just get at the creative aspect or the creation side of this, where you can just take a sort of pre-built circuit board and start to incorporate that into your craft materials. So this is just a little circuit board we've been working on, but it all comes out of that idea from the South End Technology Center. And maybe just a few other little examples here from this while we're looking at it. So,
which I believe is a flagship Fab Lab.
Oh, the South End Technology Center. Wow.
I believe so.
Great. Yeah.
Go Boston. Go Boston.
Yeah.
Any other comments or questions? Go ahead.
Sorry, I don't speak English, but I am improved today because I need to share with us. I working with some kids and with some servo motors or microcontrols. I make some projects, for example, Tinkercad with Arduino, or Arduino with
You mean Tinkercad Circuits? Is it Tinkercad
Yeah.
Circuits? Yeah.
Tinkercad Circuits, but actually let me show you something for my circuits. Working with sensors, programming and processing to sorry, I'm improved.
If you want to speak in Spanish, si quieres hablar español, quien sabe puede ayudarte.
Okay, thank you so much. This is my project. I'm mechatronics engineer, and I have some ideas for working with circuits. This is microcontrolling Arduino, and this is a little sensor using resistors to when you take this part of the resistance, the light itself, but processing makes some sound, and you can make sensors with fruits, water, and whatever you want, and using 3D models to add circuits for teach the kids in Mexico.
Okay, as soon as I offered you to speak in Spanish, you speak perfectly English. Very good.
So you would like to do this with perhaps with the models. Definitely doable. I think, Kreg, what did you use? You used a microbit.
Microbit's a great one to use. Yeah, absolutely. In this one, I was just using like AT tiny microcontrollers, but microbit is one that's super accessible and really fantastic. But yeah, any Arduino, any programmable microcontroller would be a great platform for this. And I think, yeah, like I haven't looked at it too much, but as Nettrice mentioned, Tinkercad has this thing called Tinkercad Circuits. And I do think there are some ways where you can integrate your 3D model with your circuit design much more seamless than if you were just doing it all from scratch. So definitely check that one out.
We have a question in chat to me. Could you explain how did we distribute the task between the kids and for age 7 through 9, and how did you hook them, like get them interested, especially if they're not familiar enough with digital design? Stu, I'm thinking about the spring break. Working with middle school students, so a little bit older, a couple years older. They were really, really into, a lot of them already use Tinkercad in the summer program. But if you've never done it before, just giving them a chance to play in it. if they're interested in games, so game design might be a way to do it. You know, design your characters in Tinkercad, so their favorite game characters, their favorite cartoon characters, you know, things that they're interested in. Could be the concept or the idea that they use to create their drawings, and then bring that into Tinkercad. But, you know, they don't have to know a lot about Tinkercad to do it, just really adding if they want. But I would just hook them with what they're interested in and what they do often, if not the reading itself. Go ahead, Sue.
Yeah, I think that it's, if you set aside a chunk of synchronous time, it doesn't mean that you're always talking at them or talking to them, but setting them up and then giving them a task to do and letting them go do it and then bringing them back in. So you set this kind of flow, workflow, to go back and forth so that they actually can generate and experiment and explore. But you're there in case they hit a wall.
Yeah, so we had like 3 adults kind of sitting there while the kids worked, and gave them time to work, and then they could show and share with the teacher showing what they had made at the end of the class. So that actually worked really well.
Yeah, there's a lot of conversation about the comfort level that people have when kids turn their screens off. There are some age groups where there may be some real problems about, you know, very young children turning their screens off if you're supposed to have some sense of what they're doing. But for the most part, I think that remote access to kids' lives has really shown everybody that we're guests in their home. And we need to be respectful of the kind of boundaries that kids set, and identify ways to reach out, not necessarily intrusively, but just to make sure that they're still there. And you can do that through the chat. You can do that by pinging them periodically and asking them to check in if they have any questions or things like that, just to sustain engagement.
Yes, and we're now coming to the end of our time with you. I will put in the chat a link to our website where you can find more of these activities, including the one you just saw here, the Instructables, just so you know more about it, what we're doing. Okay, Katie has a question. Go ahead, Katie. Oh,
Katie Perry.
she didn't mean
Katie
to.
Perry.
Oh yeah, Katie Perry. She didn't mean to. Yeah, that's it. Thank you. Thank you for joining us for today.
Thank you, everyone.
Thank you for your